Is this correct?
Yes, sir.
Ha.
Yes.
So I have, as a in the notes you can see that n could be positive also, negative also, fraction also, zero also. Do you remember?
Yes,
Yes
sir.
or no?
Yes, sir.
Ha. So this is enough. If you remember this, then you can get the answer proper. Like if you do this like -1, so you can observe that if we increase the this reactant, when you will increase it, what will happen? This will decrease, right? So
Yes.
it is not necessary that as you increase the concentration of reactant, rate of reaction will increase, right? So this is one of the example. Okay, Rishita and Zaina.
Yes, sir.
Yes.
Ha. Generally, generally speaking, your answer are correct. But since you are in class 12th and you know chemical kinetics, so you know this formula as well. So by this concept, the answer should be may decrease or increase. Okay.
Yes, sir.
And when it will be remain unaffected, in which case?
Equilibrium, sir.
N- uh, we are seeing rate of reaction. Rate of reaction. We study in chemical kinetics. Have we, used the word of chemical equilibrium in chemical kinetics?
No,
No,
sir.
na?
Yes.
So rate of reaction is different from chemical equilibrium. So when this value will be zero, so can you say that it is independent of the rate of concentration of reactant?
Yes, sir.
Th- Understood, Rishita?
Yes, sir.
So this is zero order reaction. For zero order reaction, we already understood that rate of reaction does not depend on the concentration of reactant, right? So answer will be the correct for zero order reaction. Yes or no?
Yes, sir.
And this will be when n will be negative, and this will be n if positive, and this n will be negative. And sorry, n could be positive or negative. So this is the fourth option, which is the correct option. Okay. This was the good question. That is why I discussed in the class. And I already told you, है ना? But student miss, it's not an issue. But if you will not try and you will not do a mistake, then you will not learn. Okay. When you have done this question, whenever this question will come in your exam or any test, okay. Yes or no?
Yes, sir.
Yes, sir.
That is why the homework is very important. This was also one of the homework in your last class homework. So please try to solve this. Just first let's read the question. So the question is half life period of a first order reaction. First order reaction is already given. Lots of question from boards comes from first order reaction. So half life is given as x. Okay. So this is T half. And further the question says that 3/4 of life period. Okay. 3/4 of life period of the same reaction is y. Okay. This is another time period where this is like T3/4. Like this is T1/2, right? Half life. Yes or no?
Yes, sir.
Yes.
And this is like T3/4. Here like 50% is gone, and here like 75% is the reactant is exhausted. Okay. So you have to find the relationship between x and y. Yes or no?
Yes, sir.
Yes, sir.
And you have only this formula with you, ln a naught upon a. Okay. You have to use this formula and try to solve this question. Let me draw a number line for you so that it can be easy visualize this question. So the question says we have the this is TF, and the question is asking for when, what is the sorry, the Y represents 3/4 of life period. So 75% is already exhausted. This is like 75%. It has been exhausted. Okay, so this represents Y. Okay, this time represents Y, and this time represents X. Okay, yes or no?
Yes, sir.
Is the question understandable,
Yes, sir.
Rishita?
Yes, sir.
So please try to solve this question. Rishita,
Yes, sir.
are you stuck in the question?
Yeah. Yes, sir.
Okay, Zana, your answer is correct. So let's see. Let's try to solve this question. So uh, T 3/4. I think you have no problem with T half, right?
No, sir.
So let's see for KT for 3/4. KT is equal to log of A naught upon A. What you have put the value of A in place of A? What the value you have put?
Sir, I put I,
In place of A, what the value of means what you have put the value of A here?
sir, I put X.
But the X is T half, no?
Oh,
Acha, you have taken like this as X and this as matlab something like what you have taken.
no, sir, I took it like how you took it. I think I'm just confused.
Okay, okay. So see, the please look upon this. The 3/4 of life means 75% already been exhausted. So how much is left? 25%, right?
Yes, sir.
So can we put it like 2.25 A naught? Yes or no?
Yes, sir.
Uh,
Yes, sir.
so when you will solve this, What you have put, Zaina? What value you have put in here?
So
Hmm?
for this, I did not really calculate. I just
Acha, from this, from number line you have solved this.
yeah, yes, sir.
Okay, okay. Okay, I'm getting there. So K 3 by 4 is equal to, uh, if you remove this one will become 100, this one will become 4. So this will become like log 4. Okay,
Yes, sir.
log 4 is what? 2 log 2. Are you comfortable with this for operation?
Yes, sir.
Okay, so kt 3 by 4 is this. So finally you will get t by 3 by 4 as 1 by k, into 2 times log of 2. Yes or no? And what is t half? Which is 1 by t log 2. Yes or no? Log 2 by k?
Yes,
Hmm?
sir.
Hmm. So can you see that, this, uh, finally we can say that yes, 2 times of t half is t 3 by 4. Understood?
Yes, sir.
So 3 by 4 was represented by y and t half was represented as x. So this is the answer. ठीक है?
हाँ, sir.
The problem which, means, anyone can, means, yeah, get is putting this one. Okay, and this one you will get hint from this, that 3/4 of life period of the same reaction. So 3/4 of the life period means already 75% has been exhausted. So how much we have? We are left with 25%. Okay, so with 25% you can solve this. Hmm?
Yes, sir.
Or alternatively you can use as log 100 upon 25. Same answer. ठीक है? Like if you have taken this 100, so obviously, this one will be 25. Yes or no?
Yes, sir.
25% is left. ठीक है?
Yes, sir.
Now I am, showing you an alternate way to solve this question, as Zana has done it. So let's see. Uh, like, this, for t half of the reaction is done. Means 100 will become 50, right? 100 will become 50, no problem.
Yes,
Rishita,
sir.
है
Yes,
ना?
sir.
हाँ. Now, if you, means, spend more half time, means another, for example, half life is, 2 hours. For another 2 hours, half of 50, which will become 25, will be exhausted. So how much time will be left? Half of 50, which will become 25. Yes or no? Tell me.
Yes, sir.
Yes.
After, so you can see that, 75% has been exhausted, which is represented by y. So we can directly say that x plus x, which is 2x, is equal to y. Okay,
Yes, sir.
if, this one become half, then the remaining concentration will be 12.5, and the half life will be x only. Can you understand this?
Yes, sir.
Yes, sir.
Huh. So the concentration is decreasing just by half. 100 will become 50, then 50 will become 25, then 25 will become 12.5, and so on. Okay. One more question I am giving you related with this question only. Okay. Please try to solve this. Question is, after 5 half-life, what amount of reactant will remain? Will remain. Will remain. So the question is, after 5 half-life, you have to tell what amount of reactant will remain. Okay.
Yes, sir.
Rishita, understood the question?
Yes, sir.
Okay. So you have a minute to solve this question, and we will discuss. So Rishita,
1 second, sir. I'm almost.
okay, okay. Good. So both of you have got the correct answer. So there are two ways to solve this question also. With formula also you can solve this question, and without formula also you can solve this question. Another T half, right? बोलते जाइए, yes or no?
Yes, sir.
For another T half, the reactant will become 1 by 8th. Then another T half, we have to go to 5 T halves. Another T half, it will become like 1 by 16. And for another T half, another T half, the reactant will become 1 by 32. Got it? So which one of you have done it like this way? Hmm?
So I just took half raised to 5. I did not draw
Okay.
the.
Okay. And Rishita, how you have solved this question?
Something like this, sir, but I didn't reach where you read.
Acha, like
I,
this only, through
yeah,
this line only. Okay. So both of your approach is correct. Another formula is also for this question is amount of reactant remaining is formula. You can write it on in your copy notebook. 1 upon 2 to the power of n, where n is the nth half life. Okay. Like if you have first half life, half has been exhausted. If you have second half life, uh, 1 by 2 to the 2 power 2 has been exhausted. 1 by 4th has been 1 by 4th is the remaining, sorry, remaining third half life. It will be like 1 by 2 to the power of 3. 1 by 8 is only remaining. Yes or no?
yes, sir.
So in
Yes, sir.
this way, fourth, then fifth. So for the fifth, 1 upon 2 to the power 5, 1 upon 32 remains. Right? Done? Correct?
Yes, sir.
Ha.
Yes, sir.
So good, you have solved this question. Uh, you have another question. Please try this question. एक second. The both question are present in NCRT. Then you have to solve this question as well. Please answer in chat box. Then try to solve this question, the second one. Okay. 4.16 you can do it by that logic also. Uh, whichever way you can try this. The second question. Can you see the second question? Hello.
Yes, sir.
Let me discuss second question with you. Please read it with me. So there is some nuclear explosion, and the product is this. This is the product, and its half life is given. Okay, half life of this element is given. Okay, which is 28.1 years. Means whatever amount of you take, like for example, it has taken if 1 microgram of strontium was absorbed, okay, in the bones of a newly born baby, okay, means when there was explosion, there was some baby who was newly born, and uh, in his bones 1 microgram of this strontium has been absorbed, okay, instead of calcium. This has been observed. So the question is asking is how much amount of it will remain after 10 years when the baby is of 10 years, okay. So what amount has been left in his body, and the question is for 60-year also, okay. And if it is not lost metabolically, means it is not lost in any other way, uh, but it has been lost by through this strontium has been decaying itself, okay. So can you see, like half life is 28.1 years. So after 28.1 years, the baby, when hit after 28 years, the remaining will be zero point 0.5 microgram. Yes or no? Tell me,
Yes.
is
Yes,
it
sir.
is it logically understandable?
Yes,
है
sir.
ना? हाँ. So I'm just asking, but however, you have to not solve for 28.1 years. You have to solve it for 10 and 60 years. Uh, Please try these both questions. We will discuss. Uh, are both are you in mathematical calculation? In the first one, 4.16. The rest is done.
Yes, sir.
So leave the mathematical calculation, no problem. Try to solve the second question, because we can do it later also. Mathematical calculation is not a big deal for you people. Hello. Zana and Rishita.
Yes, sir.
Yes.
So are you in mathematical calculation in the second one?
Yes, sir.
Rishita?
Yes, sir.
Acha, let's see. The rate constant for this is the rate constant is given. Okay, K is given, and it is asking that you have to tell the time when the concentration has become 1/16th of the value. Okay, so K is given 60 per second. So from here we will get T half, right? Which is like 0.693 upon 60. Yes or no?
Yes, sir.
है ना? Without T half we could not solve this question. Understood, Rishita?
Yes, sir.
Ha. So it is asking for 1 upon 6. Hello?
Yes, sir.
Yes, sir.
My screen is gone.
Yes, sir.
Okay, okay. Hmm. ठीक है? हाँ. So half is done. Another 1/4 is done. After that 1/8 is done, and after that 1/16th is only remaining. है ना? So you can say that, what you can say, that if you spend 4 times of half life, we will get the answer. Yes or no?
Yes, sir.
T1/16 is this. So 4 into 0.693 upon 60. Got the answer? Tell me. Hmm? What was your approaches? Can you tell me? बोलिए भाई.
So I used the formula KT is
Uh,
equal to A naught by A.
then thereafter you can get the answer. Shall I solve it by that formula?
Yes, sir.
So you are getting this only, or something else?
I haven't solved yet.
Acha, acha. Rishita, what was your approach? Hmm?
What, sir?
What was your approach?
Sure, I did that K equals to, I substituted everything.
In what? Which formula?
T equals to 2.303 by K log, that one.
Okay, okay, okay. So from there also, let's try to solve that question through that formula. KT is equal to uh, log of A upon A naught. So here will be A, and A naught. What is the remaining? We have only remaining of 1/16th of A. Tell 1/16th of value. So tell me, is this step, are you understanding this step? Sir, your voice is getting
Yes,
stuck.
sir.
Okay, sorry. So I was asking, what I have done here is I have put the concentration of A as 1/16th of A naught. Is this means can you understand this,
Yes, sir.
Rishita?
Yes, sir.
Ha. So when we will solve this one, है ना? So it will become like one. This will be cancel out, and it will become log of 16, है ना?
Yes, sir.
So KT will become 4 times log of 2. ठीक है?
Yes, sir.
When you will solve this, we know we have the value of K, right?
Yes, sir.
And we want to know the value of T here. Everything is known. So when you will solve this, T will be 4 log of 2 upon. Hello, hello.
Yes, sir.
Yes.
Any problem in any step?
No, sir.
So Zana, in which step you were stuck? And Rishita?
So the calculation.
Calculation. Which calculation? Last calculation.
I took ln, so I had to convert it to log. So
Acha,
my
in that
calculation
calculation,
became
and
long.
everything was right. The other concepts were right for you, Zana.
Yes, sir.
Acha, Rishita, oh, it's okay. It depends on practice only. When you will practice more and more questions, so you will be comfortable with the log operations. Rishita,
Yes, sir. I was doing it. I got the right answer.
got it right. That's good. So both of you have done the correct one. And so in this question, what is your progress, both of you? So you people are in calculation part, right?
Yes, sir.
Yes.
Okay. So let's solve this question. So this is question for liquid. Let me tell you. I have told you earlier also, in this notes only. In the first order reaction examples, the radioactive are first order reactions only. Zero order. Mm, examples I may have the zero order first order reactions, and this, sorry, the radioactive. process are first order reactions. So it will follow first order reaction also only. The question, acha, the question has not given that it is first order reaction. Okay, so you have to understand with the nuclear word also, है ना, कि this action, this reaction is going of radioactivity. That is why this is the first order reaction. So half life is given as 28.1 years. Okay, so from here you can get the value of k. K is A naught is given as 0.1 microgram, right? है ना?
Yes, sir.
Acha, let me tell you for MCQ's question, which I was discussing earlier. Uh, if this is the first question was about 10 years and the second question is about 60 years. So from MCQ you can directly say that if the concentration is 0.5 microgram, then it is for after 28 years only. So after 10 years, the remaining concentration will be more than 0.5 microgram. Yes or no?
Yes, sir.
Yes, sir.
If the question is asking like um, 0.7 microgram, 0.2 microgram, 1.2 microgram, है ना? And fourth one will be like zero point 0.5 microgram. So which one will be the correct option? 0.7, 0.2, 1.2 or 0.5?
0.7.
0.7. Yes or no, Rosanna?
Yes, sir.
Hello. Acha, is it good now?
Yes, sir.
Okay.
Yes, sir.
So, Zaina, you have understood the first question?
No, sir, I did not get your explanation.
Acha, acha. Okay, no problem. What I was saying is that in this question, in just let me know. For the because the half life of this strontium, okay, let me check here. I'm coming. Wait a minute. Hello. Is my voice clear to you?
Yes.
Yes, sir.
Okay. So what I was saying is the concentration has become half with every 28.1 years. Is this okay?
Yes, sir.
Huh. So the question is asking, please tell me what is the remaining concentration of this strontium in that baby after 10 years. So obviously we have taken zero point 0.1 microgram. So in every 28.1 years, it is becoming like 0.05 microgram. Acha, I have left. Is it again? Can you hear me?
Yes, sir, your voice is breaking. Like it goes for like 5 to 10 seconds and comes back.
Acha, and it would be like very speedy voice.
No, sir,
So
we
we
can't
can't
hear your
hear
voice at all.
anything.
Acha. Hello. Let me know if my voice is clear to you.
Yes, sir. It is.
It is not clear.
Yes, sir.
Yes.
Okay. Okay. Good. Let me share my screen again. So where was I? Huh. So what I was saying is that after 10 years, the concentration should be greater than 0.05, the remaining concentration. Because in every 28.1 years, the concentration will be becoming half. But after if we are taking example of less than 28.1 years, so the reaction, the concentration will be more than 0.05. Tell me.
Yes, sir.
Yes, sir.
Rishita, you have understood. Zaina, is it clear to you now?
Yes, sir.
Tell me what should be the answer if the question asked after 28.1 years. What four option you should select?
0.07.
No, after half-life, the point, this one will be the answer, na? 0.05.
0.05. Okay.
Rishita, you understood?
Yes, sir.
Now the question is about 60 years. Okay. The next question is about 60 years. Without solving, tell me what can be the answer. After 60 years, what could be the answer? The remaining concentration of the reactant.
So 0.2 maybe.
1, 2, 3, 4.
2.
Okay. Zaina. So, yeah, 2 is the correct option. 0.02. See, Zaina, what you have done, uh, the reactant concentration was taken earlier was zero point 0.1 microgram. As the question says, question says 1 microgram. Na, sorry. Sorry, I thought the question was saying about zero point 0.1 microgram. So the when it will, if it will be like 28.5 years, it will be decreased to half. So for another like more than this, like 60 years, it will be there should be the decrease in sorry, the decrement should be more or less. Yes or no?
Yes, sir.
है ना? So it will be very less, like this. The least one will be the answer. है ना? For
Yes, sir.
MCQ, if you have understood the concept, actually I have done what I have thought that the question says zero point 0.1 microgram. So that is why I have put this like 0.1 microgram is changing to 0.05 microgram. है ना? And through that I have solved this, that options. Like 0.1 microgram will change to 0.05 microgram with every 28.5 years. So for 60 years, the reactant concentration will be lesser than 0.05, right? Yes or no?
28.1 years, right?
Ah,
28.1 years, right?
28.1 years. ठीक है. So it would be less than 0.05 years, less than 0.05 microgram. Yes or no? है ना?
Yes, sir.
हाँ.
Yes, sir.
So you so for MCQs you can think and directly solve the question, है ना? And also when you solve the question, you will the answer you will be getting should be matching with your logic, है ना? So let's try to solve this question. So T half and K is T half is given, so K is given. So let's apply the formula. KT is equal to ln of a naught upon a naught upon a, है ना? So we have time, है ना? So time is taken as 10 years and it will be ln a naught will be 1 microgram and a we have left. Okay, a is a only, we have to find a. In the place of k we will put the value of 0.693 upon 28.1, है ना, into 10 is equal to ln 1 upon a. Yes or no? ठीक है?
Yes, sir.
Yes.
हाँ. So we will remove this 10 and move this decimal here. So we are getting 6.93 upon 28.1. है ना? Now we will convert this as minus ln A. Are you comfortable with this operation?
Yes, sir.
Yes, sir.
Huh. So it is like E. However, we will convert this into 28.1 into log of A 2.303. Obviously, minus will come here. 2.303 log of base 10 A. है ना? You will move this A this side. Then it will be, let me tell you, will be a rough calculation. है ना? Or you can say tough calculation. 2.303 is equal to log of A. है ना? This is 3 times. Okay. This is 3 times. Now we will solve this. Minus 3 upon 28.1 is equal to log A. Now when you will divide this, log of, so this one will be A. If A is equal to, will be 10 to the power of minus 3 upon 28.1. ठीक है?
Yes, sir.
Now rest we have to do some mathematical calculation, which is I understand, which is very, if you divide this, you will get as a 0.106 minus times. The tough thing, एक second, थोड़ा साफ कर दो. This is 0.106. Now the thing is to, the A will be the answer, but you have to calculate this. So let's see how we will calculate this. Like this is -1 plus 0.894. Okay. Now 10 to the power of -1 is like 1 by 10 into 10 to the power of 0.894. So 0.894, you will round it off to 0.9. Okay. 10 to the power of 0.9 is approximately 8. Okay. So you will get the answer as 0.8 microgram. Okay.
Yes, sir.
Yes, sir.
So since half-life has not been reached, if it has been reached, if the question is about 28.1 years, the answer would be 0.5 microgram. है ना? But answer is more than 0.5 microgram. Why? Because it is only talking about first 10 years. Yes or no? बोलिए.
Yes, sir.
हाँ. So see, you can crisscross, your answer also. So my answer is correct or not? So your answer is correct from this logic, है ना? You want to copy it?
Yes, sir.
Achha, please do. See, if in exam, let's take the worst scenario that it is coming, then the examiner will give, the data in your, this question. And if it is coming in board exam, you just round it off and solve, because examiner will know that yes, you have understood the problem, and there are some very hectic mathematical calculation. That is why you have left it. No problem at all.
Yes, sir.
Hmm. Lots of values examiner himself don't know, so that is not an issue. So it is not expected from students as well to, do this. This question was from NCRT. However, there was calculation. So we have solved this question. So anyone having any doubt in first order reaction?
No, sir.
No, sir.
Zaina? Okay. Let me know when you are done.
So,
Huh?
for this A, how did you take the power for 10?
See, the power of for 10. Uh, it's good to have us. See, if we have log of something m, and here is n, and here is x, so we can convert this as, sorry, we will convert this as n is equal to m to the power of x. The base which is here now present here now, it is raised to the power of, means this will become the power, and this base will become the number. Okay, so that is why log of 10 of for example we have 2 है ना, so we have x, so it will become like 10 to the power of x. This is an example. Okay.
Yes.
Yes, sir.
Another example you can, for example, ln2 is given like x, for example y. So the next step you have to do is 2 is equal to e to the power of y. ठीक है?
Yes, sir.
The log operations was in class 12th, but I understand that people forget because it is not generally used. But this log thing na will be used extensively in this chapter and radioactivity chapter in class 12th in your physics. Especially this first order reaction. So if you are well versed with this first order reaction, your 2 sub chapters are done. है ना? Any more problem in any step, Rishita and Zana?
No, sir.
No, sir.
Hmm. Done?
1 minute. Sir.
Hmm. So you people are having any exam in school next week?
Yes,
No,
sir. I
sir.
have test.
So you have how many exams?
So the chapters in chemistry unit.
In school?
Yes, sir. We have the alcohols half chapter and chemical kinetics.
Okay, so chemical kinetics is one of them, right?
Yes, sir.
Uh, so obviously first order reaction will be the one of the syllabus. So please solve this question, Rishita and Zaina. There are lots of question. Okay.
Yes, sir.
So please solve them. It will be helpful for your pre-boards also, boards also, your unit test also, your weekly exam also. You know, and you will always only get confidence after solving the questions. है ना? Done?
Yes, sir.
Yes, sir.
Hmm. So we are going to solve this question. Please read the question once. So question is first order reaction only, and the content here are gaseous ones. Okay. So this is little different question, a little tricky one. That's why we are going to solve this question. Okay. है ना?
Yes, sir.
So the question is about this N2O5. 2 mole of N2O5 is decomposing and forming N2O4 and oxygen. We have to find rate constant. We have time here 0 seconds, and means initially what is the total pressure. So initially the pressure of N2O5 was only present, है ना? Because data is given according to that only. And after 100 seconds, what we will see, the pressure has been increased a bit, है ना? So we have to find the rate constant according to the given data only. So the given data are very limited, and we have to find the rate constant. So let's see how to solve this question. So first of all, let's write the equation. Have you understood the question,
Yes, sir.
Rishita?
Yes.
So the question is this, and sorry. So at time 0, we have the concentration, we have the pressure is zero point 0.5 atm, and 0.5 atm of what? Of this only, N2O5 only. है ना? Now after 100 second, what we will see here, that this N2O5 will decompose, right? है ना?
Yes, sir.
So N2O5 will start decomposing, and it will be decomposing like uh, from 2 mole of N2O5, 2 mole of N2O4 form, and with 2 mole of N2O5, 1 mole of O2 is forming, right?
Yes,
Yes
sir.
or no? Ah. This is from a stoichiometric point of view also, and we have done lots of questions regarding this in any many other chapters as well. So please see, we are forming x mole of O2, and we are forming 2x, sorry, you can say moles also, we can say pressure also, pressure developed also, है ना? So x atm of oxygen we can see, and 2x at atm of N2O4 we can see. And how much it has been reacted? It has been reacted and reduced to 2x. This much atm of pressure of N2O5 is left, and 2x atm pressure of N2O4 is formed, and x atm of O2 is formed. How we have written 2 here, 2 here, and 1 here? This is according to the stoichiometric coefficient we can see in the balanced chemical equation. Okay.
Yes, sir.
Have you understood this step?
Yes, sir.
Yes, sir.
एक second, इसको हटाना पड़ेगा. So is this clear to you, this till this? Because we are going to find x value. So are you good till here?
Yes, sir.
Yes, sir.
Take. So let's see. So what we have is, we have this much pressure of N2O5, we have this much pressure of N2O4, and this much pressure of O2. We have the total pressure of. So total pressure includes this, and this, right? So we will add them. We will add them. And the total pressure is given for T or for 100 second as 0.512 atm. ठीक है?
Yes,
Yes or
sir.
no?
Yes.
So we will solve for x, which is like when you will move this, 0.012 is coming, है ना? 0.012 is equal to x. Yes or no? ठीक है?
Yes.
So pressure of N2O5 is what we have for 100 seconds. It was 0.5 minus 2x. So what the remaining would be like when you are putting the value of x in here is 0.12. We will get 0.012, sorry, 0.012 to 0.024. So when you will solve it, you will get 0.476 atm. ठीक है? बोलिए, yes or no?
Yes. Yes, sir.
Yes.
हाँ. So now after this one was now we have to do apply our chemical kinetics formula. So we have formalized KT is equal to ln A naught upon A. Okay. So here we will, in the place of concentration, we will use this pressure. So at time t, we have at time t, which is like 100 seconds, ln will be ln only. A naught is what? 0.5 pressure, right? है ना? 0.5
Yes.
pressure of N2 was there earlier. So earlier the initial partial pressure, initial pressure was of N2O5, which is 0.5. Then the final pressure after 100 second was little less, which is like 0.476. Yes or no?
Yes, sir.
Tell
Yes.
me. So till now, when you will solve this, 1 by 100 is equal to ln 0.5 upon 46, it will be like 1.05. ठीक?
Yes,
बोलिए.
sir.
So this again, you can do this like this. See, in the last step I am doing this, removing this. Now the base is not E, we have base 10. So that is why I have used this 2.303, and this will be 1.05. ठीक है? So when you will solve this log, this value is little complex, है ना? So in exam, the value will be given for you. No problem. You will just apply this value and you will get the answer. So answer will be this. ठीक है? K will be, the unit will be second inverse only, as you know. ठीक है?
Yes, sir.
Let me tell you, if the question is saying time in minute, 100 minute, है ना? So the answer would be in like minute inverse. ठीक है? बोलिए.
Yes, sir.
हाँ. So understood each and every step, or I shall repeat?
Understood.
We have taken why 0.476, because N2O5 concentration was initially N2O5 was concentration, pressure was initially 0.5. After we have solved for X, we will get the concentration of N2O5, which is after 100 seconds was 0.476. And then just we have applied the formula and we have got the answer for this K. Got it, everyone?
Yes, sir.
Yes.
Please, copy down the solutions. Rishita understood each and every step.
Yes, sir.
The special thing about this question is, first of all, this question is about pressure. Anna, everything was mentioned in pressure. We have to use somewhat of earlier concepts and found out the value of X. Through X, we have found out the final volume of the reactant, and then we got the answer by applying the formula of chemical kinetics. Let me know when you are done.